There are two very important concepts in real analysis, supremum and infimum. Now, supremum is a concept related to a set that is bounded above set. Supremum is a concept related to bounded above set, and infimum is a concept related to bounded below set. Okay. Now, let's define what do we exactly mean by supremum of a bounded above set. So, supremum written as sup of a bounded above set. Now, essentially any number u, a number u such that it satisfies the following two conditions. Number one, a is less than or equal to u for all a belonging to a. So we are talking about some set A. Okay. So this means that a is an u is an upper bound. Okay, u is an upper bound. Number two, with the thing that it needs to satisfy is that u is less than or equal to v for any other upper bound v of a. Okay, so what do we exactly mean by this? We mean by this that u is an upper bound plus u is the least upper bound. So this property actually tells that in case there is any other upper bound apart from u, that is for any v which is also an upper bound, then u needs to be less than or equal to that. That means that u needs to be least upper bound. Okay, u needs to be the least upper bound, and that is what is supremum. So supremum of a means that u is the least upper bound. So u is a supremum of a, that means u is the least upper bound. You can have a lot of upper bounds, but u is the least upper bound. Now, some things that I want to talk about right now. Number one, that supremum of a will be denoted as sup a. Okay, whatever element it is, it will be called sup a, denoted by sup a. Okay, number two, it represents, as I've just told you, represents the smallest upper bound or least upper bound. Smallest upper bound or least upper bound. Okay, smallest or least. Number three, it has to be unique. It has to be unique. This is a very important property. It has to be unique. Okay, in the definition of upper bounds, what did we say? In the definition of upper bound, we said that any set can have a lot of upper bounds. So when we were talking about an open set, 5, 8, I said 9 is an upper bound. Even 8 is an upper bound. 10 is an upper bound. Anything above than that, anything greater than or equal to 8, greater than or equal to 8 would be an upper bound. But which is the least upper bound? 8 is the least upper bound. So sup has to be 8. Okay. So that's what it is saying, that it has to be unique. It will be a unique number. Okay. Now, another very important thing that we will see in few other examples probably later is that the sup might belong to the set or it might not belong to the set. In fact, we can see that in this example itself. I have taken an open set 5 to 8, okay, an open interval 5 to 8, and I'm saying that 8 is the supremum. Now 8 is not belonging to the set because it's an open set, right? So, but still it is the supremum of the set. So, it might belong, it can either belong to A or maybe not. So, these are very important points about supremum that we should know, okay? Now, suppose we have, let me just prove for you the uniqueness part. Okay, let's try to prove that. Suppose we have two supremums. Two suprema. The plural would be suprema, okay, for the set A that we are talking about, okay, an arbitrary set A. So, say U is sup A, also V is sup A, okay. Then, according to the definition, what do we have? U is a supremum, that means U is less than or equal to V for any other upper bound V, right? Now V is a suprema, V is also a suprema, so V also has to be less than or equal to U for any other upper bound U. So now these two things, what do they tell us? If U is less than or equal to V, V is less than or equal to U, that means they have to be equal to each other. So they have to be equal to each other, and that proves the uniqueness of sup. So supremum, therefore supremum is unique. Okay.